Mark Jessup, VK5QI, and Trevor Warren, new member VK3TWC, and I think Greg, was it Greg? Sorry, Chris Gomersall, are here this evening to run through a presentation on Project Horus and some of the opportunities that Trevor's going to progress with within EMDRC as we go through the year, COVID allowing, of course. But I'll keep it brief, and I'll hand it over to Mark, who'll do the first half of the presentation, and then Trevor will continue on with the more localised content. So, gentlemen, I welcome you this evening. Thank you very much for giving your time generously to present to the club this evening, and I hand the gavel over to you for your presentation.
No worries. Thank you very much. Thanks for having us. And apologies for the bigger AREG logo on the front slide. I figured I'd have to do some advertising for AREG over here in Adelaide. So tonight's presentation, I'm going to give a bit of a rundown on Project Horus. So a ballooning group now underneath the banner of AREG, running out of Adelaide, and talking about, so hang on, let me get my mouse cursor in the right spot so this works. Go through a bit of history, where we came from. Some of the basics of a high altitude balloon flight, though it sounds like it's nothing new to quite a few of your members, given you were doing launches long before we were. Run through a typical launch day, talk a bit about the regulations that are involved, and then how we decide when we're going to launch and what's going to happen during the flight. Go through our tracking and telemetry systems, which we use on our flights and which we are also giving away for free to everyone who wants to use them. And also talk a bit about imagery systems that we've been using and some new payloads that have flown recently. So Project Horus, our first launch was in February 2010 by a guy by the name of Terry Baum, who's in the center of that photograph. He saw an article, I think it was from some students at MIT, saying they were able to launch a balloon for about $200. That's complete crap, as we found out. Yeah, he did the first launch in February 2010 with a basic camera payload and some very, very rudimentary tracking. Though I must say, this was tracking with GPS receivers and sending telemetry down via RTTY of all things. As of this year, well, noting we haven't done any launches this year, we've done a bit over 55 launches. The number's a little bit vague. We lost track around about 50. There's been a couple small launches, which kind of count, kind of don't count, somewhere between 55 and 60 at this point. We've done launches for a lot of universities, University of Sydney, University of Adelaide, done a few launches with them, and UniSA. In our early days, we did some promotional launches with Lonely Planet. We launched a whole bunch of cameras for Rising Sun Pictures, which took video footage, which was actually used for reference imagery in the movie Gravity. Anyone remembers that one? We've done launches with a STEM group called Launchbox, Tea Tree Gully Library, which I'll show you a photograph of in just a minute. And for quite a few years running until COVID kind of killed everything, we were doing yearly launches with the International Space University and their Southern Hemisphere Space Studies program, which was also related to UniSA. Unfortunately, the last couple of years of that have been only online, so no in-person balloon launches for them. And I want to make sure to get my focus over here. Cool. So some basics of a balloon flight. Up the top, we have a latex balloon. These come in many shapes or many sizes, from small to medium to really, really big. And we fill them with some kind of lifting gas. We use helium. I have done launches with hydrogen. Yes, it is safe if you're careful. Below that, we generally have some kind of parachute because it would be nice if our payloads landed instead of impacted the ground. We always have some form of radio telemetry tracking system, usually more than one. And then we have our payloads, and our payloads consist of all sorts of different things over the years. There's been effectively sensor packages, science experiments. We've always launched cameras, of course. Everyone likes to get some neat pictures from high altitudes. The occasional stuffed animal, such as Anstey the echidna, who flew twice without a spacesuit. So Anstey unfortunately did suffocate on the way up and froze on the way down. But Anstey did get returned to their to her rightful owners, the Tea Tree Gully library. And yeah, very, very good photographs from these flights. So I'll run through a typical launch day, including some videos as well. So our launch sites, we have a couple of them which we use, usually about an hour's drive from home, and we usually try and launch pretty early in the morning if we can. So we might be getting up quite early, far too early for me normally, throwing antennas all over our cars. Again, I've seen the Fox Hunters chase cars. This is nothing compared to that, but we do our best, and head off for our launch site. So we get to our launch site, we start filling our balloon, preparing all of our payloads. Filling the balloon can take some time depending upon what we need to do. In this particular case, I think there's 3 cylinders of helium there. I'm pretty sure we actually only used 2 of them. I'm not sure what the third one was for, but it could take us a good hour to prepare for a flight and get everything ready to go and tested. We then start, we tie all the payloads together with string. I just should note that pretty much everything's held together with string and duct tape in this particular hobby. And then we start hoisting the balloon up, raising it up into the air, and get ready for launch. And if I think this next slide is a video, here we go. Hoping this works correctly. I'm just going to check that yep, optimize the video clip. So this is a bit of a video montage of a launch. So we used to have access to a wonderful garage to fill in, which made filling very, very easy. We could fill the balloon and very accurately determine the amount of gas we'd fed in to the balloon by measuring the neck lift, the force pulling upwards. Unfortunately, we now launch outdoors. It's a lot harder to do that. And then, as you can see, we start releasing the balloon up into the air, paying out all the payloads. It's worth noting that we don't have anywhere near as much length in our flights anymore. We changed the way we do things a few years ago. And then usually there's some kind of countdown involved, and we let go. And off it goes, up into the air. And I'll just jump to the next slide. So once the balloon's launched, we all head off. In our cars, we have reception of the telemetry, which provides us with the position of the balloon all throughout the flight. We've changed our telemetry systems over the years. I'll go through that in a couple of slides, but we've gotten to the point where our telemetry is extremely reliable. So we have tracking the entire flight. In our cars, we've got mapping systems, which show where we are, where the balloon is, and fairly importantly, where the balloon is going to go using prediction models, using the global forecast system weather model. So in this case, we can see the balloon, bottom right-hand corner, my chase car, the blue car, and a line showing where the balloon is predicted to fly, burst, and then land based upon parameters that we enter into the prediction software. It's worth noting, this is a recurring theme throughout this presentation. The bottom of some of these slides, there's a GitHub link. Everything that we've developed for Project Horus is open source. All the software is open source. You can download it and you can use it for free, and you can modify it if you choose to. During the flight, we may capture some really great photographs. Sometimes they get sent down to the ground via radio link as well. And when you get to high enough altitude, you get this wonderful black sky effect. It's worth noting at this point that we definitely don't get to space. Space is a lot higher than we can get to with a latex balloon. It's also worth noting that in most cases, the actual curvature visible at this altitude is fairly small. And what you normally see in photographs or video is lens distortion. So just bear that in mind when you go see videos of balloon flights. Often you are seeing lens distortion, not actual Earth curvature. Still looks pretty good regardless though. Once we get high enough, the balloon will stretch and stretch and stretch, expand as the pressure decreases, and eventually it will burst. Or sometimes we cut the balloon away. We've got a cut-down system which we use, where if we choose to, whether it's a case of we want to improve our chances of recovery, or whether we are forced to, we may get a direction from air traffic control, we can choose to cut the balloon away and terminate the flight early. In this case, you can see the balloon heading off at a very, very, very fast descent rate, given there's no payload below it. and our parachute deploying in the Cutdown payload floating in the breeze on the way down. After burst, we are rushing towards the landing site. So again, the mapping systems we used will give us a time to landing, estimated time to landing, and they'll essentially tell us where to drive. We'll have a navigator directing the driver to get into the right position. Here in this example, I'm waiting at the town of Hamley Bridge, waiting for a radio sonde to land. Not an actual flight of our own, but a meteorological radio sonde flight, but same software that's used. And if we get there in time, as we often do, we can watch it land. This is fairly common now. The prediction software makes this surprisingly easy to do. You follow the predicted landing spot, you hang around, and often you get to the point where you can just look up in the sky and there it is, falling out of the sky underneath the parachute to land, hopefully in a nice open paddock to make life a lot easier. Isn't always the case, mind you. I think, oh, there's sound on this one. This was actually the first one that we saw land. This was back in 2011, I believe. Yeah, well, we got quite close to it, and yeah, it was landed pretty much right in front of us. Again, all because of the prediction system. Sometimes we get close enough that the cameras on the payload capture us waiting for it to land, and that was the shot from the balloon of that previous video showing the chase cars. So a bit on regulations. Just give me a second. Things have changed a little bit since the mid-90s, I should say. There are some pretty serious regulations governing the launch of what they call unmanned free balloons. So in contrast to a hot air balloon with a pilot. Civil Aviation Safety Regulations Part 101.E covers this category. There are a range of balloon sizes, small, light, medium, and heavy. Small is essentially someone releasing a party balloon outside, effectively. There's some debate over what exactly the small balloon category means. Depends who you talk to at CASA. There's the heavy balloon category. So think NASA balloon-borne floating telescopes, 1 ton, the kind of thing that crashes into cars at Alice Springs, if you remember that story. Medium category, which seems, I have no idea what the point of the medium category is. It's between 4 and 6 kilograms of payload. It makes no sense whatsoever. But between 50 grams and 4 kilograms of payload, we have the light balloon category. This is what we fall underneath. To be able to launch a light balloon, you have to seek approval from the Civil Aviation Safety Authority, CASA. There is a fairly involved process to do this. It takes some time. You have to provide a lot of documentation and evidence that you know what you're doing. And eventually, after paying them some money, you obtain an instrument from them. And an instrument is, I use the term personal law. It is legally binding, and it basically says what you're allowed to do. So the instrument on the right-hand side here is my current instrument, and it permits me to release a number of balloons from a range of launch sites. However, some of these launch sites are within restricted airspace, in the case of one of them in particular at Auburn, within the airspace of RAF Edinburgh. I have to coordinate with the RAF, with the airspace owners. I have to coordinate with the RAF Edinburgh. I have to request a notice to airmen. The name's that's changed recently, I believe. Notice to aviation people, I believe. Not sure what it's called anymore. But 72 hours before the launch, I have to contact CASA and request a NOTAM be released. And then, in the case of our approval, just prior to launch, I have to call up the local air traffic control tower and request final permission. And it is not unheard of for them to delay launches. Depending upon where we're launching from, ATC will delay us. They'll tell us, please hold on for 10 minutes. And unfortunately, that can happen at the worst of times. The background noise there we go. We've had cases where it's been windy at the launch site and raining at the launch site, and we've been asked to hold on to the balloon for 20 minutes, please. Yeah, it wasn't fun. And sometimes ATC will actually follow the flight using online tracking systems, which I'll discuss shortly. So we're going to launch a balloon. We would like to not guess about what's going to happen. We want to make sure we're going to recover our payload. We want to have the highest chance of recovering the payload. So we use what's called the Global Forecast System. This is a weather model, a predictive weather model from the National Oceanographic Administration in the US. And it provides about 7 days of forecasting. I can actually go a little bit further, but the prediction accuracy is pretty rough at that kind of time into the future. So to make use of the model, there's a range of prediction utilities that are available. All are open source. And the one that we use is the HAB online predictor. And I'm just going to try and do a live demo of this. So just give me a second. Whoops, let's go back to this page. And I'll just run the prediction again. So this is the HAB predictor, predict.habhub.org. Notice to air missions. Thank you very much for that, Luke. And what this shows is a prediction of the flight path for a balloon flight from Adelaide Airport with an ascent rate of 5 meters per second, descending to 30 kilometers altitude before bursting and descending to the ground with a estimated landing descent rate descent rate at sea level of 5 meters per second. And we can see that it's going to head a fair way to the east. Now, to visualize this somewhat better, I'm just going to use Google Earth, and this shows the path. And we can see the balloon ascends, and then it turns the other way. So what's going on here? It's gone up, it's headed east, and then it starts heading west again as it gets to a high altitude. So what's happening here? Just give me a second, and I'll get back to the presentation and show you. This one here. So this is a visualization of the Global Forecast System model. The blue and the colors represent the wind speed. And if I click somewhere, I'm pretty sure it'll show me the wind speed. Yep, 24 k's an hour. And I can step through different altitudes. The model refers to these as pressure levels, but at ground level, you can see the wind is coming from the southwest. But as we head up in altitude, the wind speed increases a bit more, increases more still, then slows down and starts going the other direction. This is fairly typical. We often find that flights, as they get to higher altitudes, will start heading back the other way. Depends where you are, of course. But just an example that wind conditions on the ground are not necessarily a good representation of what wind conditions are in the upper atmosphere. This is why we have these models to use for predictions. Very, very important. Let's move on. Okay, so on to tracking. So if we don't have good tracking of our flight, we have a very low chance of recovering our payloads. And our payloads might be quite expensive. They might be quite valuable to us. We want to make sure we get them back. At the very least, the very minimal case, we want something that we can track with radio direction finding as a backup. But it is 2022. We can do markedly better than that nowadays. And we have low-cost GPS receivers, microcontrollers, and radio transmitters to allow us to send down decent amounts of telemetry data. Ideally, we want to be able to provide positional information for the entire flight, all the way up to the burst altitude and back down again. Nominally, I prefer fast updates, 5 seconds or so between positions. It's useful if it can run for a few days. That way, if it lands somewhere out of reach, at least quickly, you can get there the next day and it will still be transmitting, which just makes it a lot easier to recover. We want to be able to receive it over a long range. Not just for our own purposes, but so others can get involved as well. It has to operate at the environment, the environment that we expect at those altitudes. So, very, very cold for certain parts of the flight, and it must always work. This is a part of the flight that has to be the most reliable thing. If this fails, you've lost your payload. Obviously, you can fly more than one for backup. So we've gone through a few different tracking systems. When we started, Terry followed the model of a group of balloon hobbyists from the UK. Now, interestingly, in the United Kingdom, you are not allowed to use amateur radio in the air. in aircraft or on balloon flights. They actually prohibit it specifically. What that means is that they were restricted to using the ISM bands only. So particularly in the UK, that's the 434 megahertz ISM band, and they were limited to 10 milliwatts. That's all they had to work with. And with that, they had no issues at all. They standardized on actually using RTTY of all things. It was a very easy to generate using an Arduino microcontroller and a couple of very basic radio transmitters. We used that initially as well, running 25 milliwatts, which is our ISM band limit, though we were running underneath an amateur radio license. And you know, it does work fairly well. RTTY, of course, has no forward error correction. You lose 1 bit, you've potentially lost the entire telemetry packet that you're trying to send. We decided we could do better, and we did. So this particular payload got retired in 2020. We have flown APRS. APRS is pretty popular for these kind of flights, and in the US in particular. It helps if you have a good APRS network to receive you with, though. Over here in VK5, once we head to the east of the Adelaide Hills, our APRS coverage pretty much dies off. I mean, yes, obviously when you're in the air, APRS coverage is very good. However, once we land, it just disappears completely. So never really worked that well for us. There are other issues with APRS as well. Realistically, you can't transmit at high rates because you will potentially congest the APRS network. There are other issues with just efficiency of the modulation. AFSK, so FSK over FM, is relatively power inefficient. So yeah, we had some issues with that. So we ended up moving to a new system. So our current telemetry system makes use of reprogrammed radio sons. So the telemetry payloads that are launched by the Bureau of Mineralogy twice a day out of many airports, including Tullamarine. We collect them. The method that which we track and recover them is a whole nother talk by itself. I'd love to give it one day. But if you could search for Radiosonde Auto RX, you can find out more about that. But anyway, we recover these and we reprogram them. So David Rowe, who developed Codec 2, and I developed a new modem to use with this. We chose to use 100 baud for FSK and also make use of forward error correction. This resulted in quite significant performance improvements over RTTY and very significant performance improvements over APRS, in part due to the lower data rate. However, we still get position updates every 5 seconds, actually every 3 seconds, I should say. We only use 25 milliwatts. The payload runs for a good 2 days off of 2 AA batteries. Nowadays, we can also add on external temperature sensors, temperature, pressure, and humidity sensors. And it can be decoded at very long ranges with a very, very basic receive system. Just the other weekend, I did an example of this, where I was receiving one of these payloads from 200 kilometers range with a quarter wave monopole antenna, $5 from AliExpress, and an RTL SDR, and no preamplifier. That was all I was using. Again, everything's open source. The decoder is open source. The firmware is open source. The software to track and recover these is open source as well. You can go and grab them yourself. And let me go to the next slide. So how do we handle tracking? So we make use of the HAB hub mapping system, which is a front end for the Habitat database. Wonderful naming scheme there. And it makes use of multiple receivers. So we have receiving systems in our cars, of course, which will receive and display the telemetry locally. They also upload telemetry to the web for display on the tracker.habhub.org map. Others can receive as well, and their telemetry just provides us with some redundancy throughout the flight. So we always have a position available to us. It's worth noting that my particular instrument specifically requires that I have tracking available on HabHub during the flight. So I want to make sure that it works. So the more listeners, the better. Right, so this is a screenshot of the HabHub tracker showing many, many listeners. So the little antenna icons around Victoria receiving a flight from quite a while ago now that drifted into Victoria. And so we can see that these stations are receiving at quite a reasonable range. And there's the balloon in the middle, and there's also a predicted flight path as well, a little bit hard to see. And anyone can visit this site and see what's going on. So how do we track one of these flights? How do we receive the telemetry? It does not require very much nowadays. If you're using a traditional receive setup, you would need a 70 centimeter SSB receiver. So think FT817, ICOM IC7000, 7100, those kind of things. Some scanners will do it as well. You need some kind of antenna. You don't need much for this telemetry. It's 100 baud. It goes a very long way. Quarter wave is more than sufficient. You feed that into a computer running some software that I wrote, and that will decode the telemetry, show it on your screen, and upload it to the web. It is the 2020s now. We have software-defined radios, which makes it even easier to get into it, because a 70 centimeter SSB receiver can be quite expensive. I'm looking to my left at my IC 9700 and thinking how much that cost. But realistically, you don't need much more than an RTL SDR, Realtek software-defined radio, the kind that you can buy for 20 bucks on eBay. No issues at all. They work just fine. Again, antenna, quarter wave, works just fine. You feed that into your computer, you run some SDR software like SDR++ or SDR Sharp or SDR Console, and that can feed the decoded, the demodulated audio, I should say, the upper sideband demodulated audio into the telemetry decoder, and off we go. So live demos. This is always fun. Let's check if this was going to work. Where are we? Okay, here is SDR++. I'll bump up the gain slightly. And in the middle of the screen here, we can see the signal from a tracking payload I currently have sitting outside. If I turn the volume up on the other radio that I've got next to me, you'll be able to hear the telemetry. And that was one packet, 4 FSK. And then if I can just bring up the decoding software, which is this one here, and start it, what we're seeing is it's receiving audio. We can see the spectrum at the top of the screen, and it's just decoded a packet. No problems at all. Then if we go to the HAB tracker, we can see the balloon on the map. And there it is, and that's my house. So at the same time as the payload's being received by the receiver, which is sitting behind my laptop, it's actually also being received 60 kilometers away by a receiver up on a hill to the north of Adelaide with a quarter wave vertical and an RTL SDR. So just to give an example of how easy it is to receive this, 61.7 kilometers away, no problems at all. So with a very, very modest receive setup, anyone can be involved to help track these flights. Another useful thing about the HAB database is flight statistics. So one of the reasons which we moved away from APRS for our flights, or we didn't really use it very much, was we have this thing about in Project Horus flights about audience participation. It's the best way to put it. We like the people that are tracking our flights to really feel they're getting involved. They can see their call sign on the map showing they've received telemetry, and after the flight, we show them a bit of thanks. So the HAB database can produce this wonderful little pie chart showing who received how many packets, and it can become quite competitive. So who received the most packets, who received it from the lowest altitude, who received it as far down as possible, you know, that kind of thing. It's good fun. It's a great way to involve people, many people in your flight. And again, you can go online and you can get these statistics for the flights that you run. And in this case, this was a flight, I think this was actually a flight from the Riverland recently, judging by the call signs. And there were a few VK3s in there as well, I see. Other payloads that we fly, we have what I call the flight control payload. This is the Cutdown that I talked about earlier. There's effectively a hot wire that can cut through the string, melts it, and then the balloon goes up, the payloads go down. I can command this from the ground, easily can command it from 200 k's away, no issues at all. And this is really just a backup. It's for emergencies, in case we get called by the ATC for some reason, but it's never actually happened. We more often use it to increase our chances of recovery. So if we see the prediction says it's going to land somewhere close to water, for example, we might choose to cut the balloon down or cut the payloads down earlier to make sure we avoid that. The only problem with this particular payload is it does use a proprietary modem, LoRa. Not a particularly big fan of it, but I haven't been able to replace it just yet. It is as open source as I can make it though. Now on to imagery. So we've flown many GoPros, we've flown many still image cameras. That's all well and good. You can get the pictures after you recover the payload, but it's really cool to be able to see it during the flight. It provides far better interactivity than just, recovering it after the fact. We've got a few imaging payloads that we've used. So we have flown SSTV. This was a flight in 2018 with a 2-meter transmitter. And we flew the Scotty 2 mode, not particularly high quality pictures, I should say. It was received in VK3 though. It was received in Melbourne during that flight, which was pretty cool. That payload is currently on loan to the Riverland Radio Club for a flight they're going to be doing in a few months' time, I believe. But again, analog imagery, pretty noisy, pretty low quality. We think we can do better. And we did. So I think it was in 2017, actually, David Rowe, again, Codec 2, we developed the Wenet imagery downlink system. So this is actually running at 115 kilobits per second FSK. We have some very good forward error correction on this particular downlink, and we only run 50 milliwatts. So this is QRP imaging, if you will. And with, you need a little bit of gain on the ground, but not too much. We can receive imagery from 100 k's away. And we can get a 1080p, so 1920 by 1080 pixel JPEG image in about 30 seconds. Pretty fast. This is an example of such an image. And I was going to do a demo here, but I think it's getting a little bit dark. It might not work so well. Oh, there we go. Okay, it's getting a bit dim. But this is a live receiver. This is running the Wenet reception software. Again, open source, runs on a Raspberry Pi, uses an RTL SDR. And if we wait just a minute, we'll see an image coming through. And this is what users of this will see. And this is how you can see how fast it is. Just the camera isn't quite handling the dark at the moment. So again, images coming through during the flight. Very, very cool. And the other cool thing about the Wenet system is the image is broken up into packets, and the packets are all sent to a central server. So if one receiving station misses some packets, but another receiving station receives them, they all end up in the same place, and the server will combine those packets to make a complete image. Diversity, spatial diversity reception, if you will. So again, we like to get multiple people receiving during these flights. They all contribute to producing really cool live images from the flight. It's awesome. You do need a bit of gain. 5 elements is actually usually enough for this, though our prime receiving site, we'd like to have a little bit more than that if we can. And again, yeah, RTL SDR and some open source software. It's really good fun. Last year, we decided to go one step further and do live video. So I know there's a big ATV scene over there in Melbourne. We're running DVB satellite. And we were running on the last flight 1 megasymbol per second. Only SD video. We figured we'd start small. We were running about 800 milliwatts of transmit power on 445 megahertz. No worries transmitting there in VK5. There's no one using it. And the payload shown there on the right. So it was a Lime SDR Mini as the SDR generating the DVB-S signal, and an LD MOS power amplifier. And there was a quarter wave monopole below the payload. And it went pretty well. This was a radio test flight. It was cloudy, and the video was pretty terrible because it was cloud. But we had reasonable reception throughout the flight. There are certainly improvements to be made, and we also streamed the entire thing live to YouTube on Hayden Honeywood's Ham Radio DX channel. And that was good for audience engagement, people joining in and seeing what's going on. There's an example at the bottom left of someone back in Adelaide receiving the video using Minitune. I'm sure some of you might have heard of that. You can also receive it using open source software as well, using RTL SDRs. So anyone can get involved. This does require a fair bit of antenna gain, I must say, though. It's definitely a lot harder to receive. So what are we up to next? So I will admit things have slowed down a fair bit for us. with COVID really hasn't helped, and also just time, trying to get time to get many people together. It takes a lot of people to do a reasonable sized balloon launch. You want to make sure everyone's involved. So over the last year, I've actually been mentoring other groups. So Melbourne Raspberry Pi Hackers Group, Trevor, you'll hear from later on. There's been a couple of groups that have started doing more commercial style launches out of Adelaide. I've been helping them get telemetry going. And also the Riverland Radio Club up in Renmark, they've started doing their own balloon launches as well. So I've been helping support them, providing advice. And again, a lot of my time is actually spent developing the software which supports these flights. So the hub tracker, the telemetry systems, the telemetry payloads that people were using, which are probably the easiest way to get into doing balloon launches and tracking it reliably. The chase car system, Chase Mapper, and also the radio son tracking software to be able to recover our free balloon trackers that fall from the sky. However, we are planning some launches for Project Horus. We're hoping probably April, the way things are going, to try and do another Wennet imagery flight. We want to try and image a sunrise or a sunset, which could be pretty cool if I can get the camera to work properly. And we're hoping possibly mid-year to do a reflight of the DVB-S transmitter. In this case, we're going to be using a different antenna, a quadrifilar helix, if I can get the damn thing to work properly. Very, very challenging to get right. So that's it from me. I'm going to pass over to Trevor and we'll move on. And if you have questions, put them in the chat and I'll answer them in the chat while Trevor's talking.
All right, thank you. Yeah, in the interest of time, yeah, we've got a little bit over 15 minutes remaining. I also wanted to open up for Q&A at the end. Mark, thank you for that. Mark has been instrumental in supporting us. It's been a very long road. It's been a long journey. It's been a very rocky journey for us as well. We are almost there. We are almost there. We are nowhere near the level of expertise that Mark has and the number of runs that he's got on the board. But we intend to get started later this year. So fingers crossed, and all of you are welcome to hop onto that journey and be part of the initiative. I've got a few slides in this. I'm sharing that with Chris as well. So I'll cover a couple of slides, but I wanted to give some of the others in our group who have been with us right from the start to help with the presentation. So yeah, just 4 key areas. What does the current HAB team look like? So I've been with the group now with EMDRC for a little bit more than a year. Most of the other members have recently joined. Some of us have our licenses. I'm a standard, some of the others are foundation, and the others are considering getting their foundation as well. So we'll get there. We'll get there. I'll do a quick introduction of the team. We'll talk about what we've done so far. There's tremendous amount of work that's been done so far. I won't be able to go into tremendous detail. The intention here is to basically just share with you where we are within our journey, and what might that journey look like for rest of this year, and how you might want to jump on board and be part of that experience. Okay. And then the schedule of activities, which is again tentative, but it's something that we are putting forward because there's a lot of prep required for each of these events. So you've got to think months forward. You got to think ahead. One of the pictures from one of our most recent test setups. I mean, we did a simulated launch. We basically filled a little gas. We tested things out. We did it outdoors. It was just around the city. But yeah, just basically doing a simulated launch. And we've done a few of these. We definitely have got a bit rusty. We need to get back again into it. But it's basically just a picture from one of those simulated launches. So what does the team look like? Chris, I just quickly just step through the team as it currently stands. Chris has been is basically a website designer. He works with clients designing websites. He also designs and builds robots. He is a trained blacksmith who builds ornamental swords. Chris brings to the EMDRC HAB team extensive experience with flammable gases. So Chris is our man who manages the cylinder, who's basically doing all the fittings. Each one in the team has their own strengths and plays to their strengths. And I think that is the beauty. We are a very small team, and hopefully over the year, with your support and with others intending to join, we will grow that team. Right? Tristan, his background is hardware development. He's a firmware developer. Tristan has always been a champion for custom platforms. So Tristan has always wanted to fly a custom platform. We aren't there yet. I'm trying to basically keep it as simple as possible for the first few launches, get a few runs on the board, and then move on. But one of the things that Tristan wants to help us out with, and which is on our roadmap as well, is basically a custom platform for the launch, and we'll get there. We'll get there at some point. Greg, he's an Arduino enthusiast. He's a landscaper by profession. Greg's main experience and capabilities lie in the Arduino space, and Greg has been with us for a really long time. Rohan, software engineer by profession, a mechatronics engineer by degree. Rohan is currently a foundation license, and he's part of the EMDRC group as well, EMDRC group as well. Rory has just recently relicensed. He works for the comms industry. Rory is really, really helpful when it comes to understanding what kind of equipment to use in the field. He's got a van fitted out with some really, really nice VHF, UHF gear. So Rory being there with the team really helps. And Rory's got some good contacts in the industry as well. So tremendously helpful. And that's myself. I run a few groups in Melbourne. I run a Coder Dojo, a code club for kids. And in addition to that, I've also been with a team of volunteers. I've basically been running the Melbourne Raspberry Pi Makers group. And this by far is one of our largest initiatives. And as part of the EMDRC HAB initiative, we want to see how best we can grow the HAB team, and we can basically bring new members into EMDRC as well. So just a quick summary of what's been done so far. I know it's 8:47. We started off by exploring many different payload platforms, and you heard Mark earlier talk about, he's done XSTV, he's done streaming video, and a lot of other complicated stuff. At this point, we are going with a very, very simple platform. I won't go to technical details right now. We can talk about that at a separate session. But we started out initially with the Pi in the Sky, which is a custom off-the-shelf platform that we procured. It was pretty expensive, I think some $350. But at this point, our thinking is a combination of what Mark has suggested, which is the radio sound and probably the Pi in the Sky. So we want to keep it simple. The payload platform will evolve over time. And I think this is a great opportunity for individuals within EMDRC to come forward to help with the roadmap for the platform, but also help with design, with build, with test. There is tremendous amount of testing involved. I can't tell you that there is a lot of testing involved before we actually get this up into the air. We've done a bit of testing on the ground. We've done some amount of testing in the air. We've never really launched. And when you go from that design, build, test, and there is tremendous amount of learning involved. There are many mistakes that we make along the way. So our payload platform, when I say we've got one for the initial launch. And as we evolve through the year and over the years, the payload platform will change. And we are keen to get other people to come help and contribute. CASA approval. Mark spoke earlier about CASA approval. We've got our CASA instrument. We had a wonderful individual who was working with us, a guy called Andrew. Andrew, unfortunately, has moved to South Australia. He actually now works with the Australian Space Agency, which is fantastic and a great opportunity for him. So Andrew was instrumental in working along with us and with Mark in helping us put the instrument together. The irony is we've had the instrument for the last probably around 6 months. We've not really been able to use it. And hopefully that will change in the next few months. But fingers crossed, we see how we go. Right. Launch site options. So Mark spoke earlier about launch sites. And as you know, there is legislation, there is regulation. It is very, 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 very important that people know what they're doing when a launch is concerned. based on the guidance, the support, the assistance that Mark has given us, and a lot of work that we've already done, we've identified potential launch sites. We've driven out to these launch sites. So along with Chris, along with Greg and some of the others, we actually spent a day in the country just driving around. In fact, Chris has gone driving out on other days as well, just driving into towns, looking for potential launch sites, doing modeling, trying to work out where the balloon might go. I mean, modeling and potential launch sites and how you work out what might work is a whole talk in itself. But the bottom line is we've got approvals for 2 launch sites, and it is highly likely that we will do our launch from the launch site provided by the Ararat Council. So we have an agreement. All we need to do is basically lock in a date, confirm that we've got our insurance sorted out, and then basically we can go and confirm the launch with the council. The bit though is, the unfortunate bit is you have to drive out a fair bit because of the restrictions that have been imposed on us in our CASA instrument. And that's primarily based on the fact that when you do your modeling, you realize that you can't really stray into airspace. So you want to stay out of the airspace. You want to make sure that the balloon that you're launching is not basically going into an area which is going to cause us a lot of grief. And that's the reason why you got to go far out into the west. And Ararat is a region that worked really well for us. We can talk about it on a different presentation, a different session, as to what does modeling look like, why did we choose that, what were our options, and potentially what the recovery zones might look like. So we've got an idea of where we think things will land. But again, as Mark said, depending on the weather, that can change. We've set up and built our tracking vehicles. As you heard Mark earlier mention radiosondes, which BOM launches twice a day. And by the way, BOM actually launches them from 2 sites in Melbourne from Telemetry Airport. So while we are not allowed to launch in Melbourne, the Bureau of Meteorology basically launches sondes twice a day. So 10:30 in the morning and 10:30 at night. And we actually have got these trackers set up, which use the code that Mark and his team have written. A beautiful piece of software, works 99.9% of the time. Excellent interface, really, really neat. And Mark's work is just fantastic. So we've all got those trackers set up in our vehicles, but I've also got it at home. So I'm actually tracking, receiving, uploading that data for every launch. My setup is not great, but it works. And what we've got in our cars is also something that has evolved over a period of time. So we'll actually do, and as Mark mentioned, we should do a separate session. I will organize, I'll work with Mark and with John and Martin, and we'll have a separate hands-on session, because the intention is for you guys to have, and those of you who are interested, obviously, to have your own stations. Either you can have it at your QTH, or if you basically want to have it in your car and be part of the group and come and chase and come and recover, and we go and have a pub meal, so on and so forth, and basically join in the fun. But yeah, we'll have a separate session about setting up the equipment in a chase car. EPA WIC. Now this was an interesting one. Chris did a lot of work for us over here. Just when we thought we were out of the woods, just when we thought that we had everything sorted out, and this was basically a year and a half into the journey, we were hit by the EPA WIC legislation, which basically meant that any balloon launches in Victoria, all balloon launches were banned, but you needed to get special permission. Chris did a lot of work in that area. We've got that under control. But as you see, it was a rocky road. There's just been one hurdle after the other, one hurdle after the other. I'm glad we've got this far, but it has been an interesting journey and a lot of interesting lessons learned as well. We've developed detailed checklists. We've done a few simulated countdowns. We've basically we've tested things out outdoors. We've never really done a launch. And I think we've got a bit rusty since we've not really done anything for the last 6 to 7 months. It is time for us to get back, put things back on the agenda, get people involved, those among you who want to come and be part of it, have fun, learn, share, help build. But we need to get back. We need to do these simulated launches. We need to basically run through a countdown. We've got all of this packed down. So we've got all these checklists, everything is there. we need to get back into it. And it's high time that we do that. So when Chris talks about it and goes through the slides, he will cover off the schedule that we are putting forward and that we are recommending for rest of this year. This was the last hurdle. We are yet to get there, so I don't have confirmation yet. But one of the other things that we were hit with was public liability. I won't go too much into technical detail. There's a lot of, we can talk hours together about the challenges that we worked through over the last 2.5 years. But as you know, public liability is essential for a launch, simply because the council who provides us that space, or anyone who provides us that space, all the other councils, the Northern Grampian Council, the Ararat Council, whoever it might be, has a clause that very clearly states that you need to have public liability covered. And that was one of the other issues that we ran into. So I won't go into detail, but if anyone's interested about hearing about the challenges separately, we can talk about it over a coffee. Procurement of balloons. We basically procured balloons. We've actually got our gas cylinder sitting with Chris. Chris, or was it Rory? We've been paying for it for the last 1.5 years. So Chris and I have been sharing the costs. The gas cylinder is just sitting there. We paid around $350, $400 for the balloon. The CASA instrument costed us around $500. So in total, from our own pockets, we've probably gone a little bit over $1,000, $1,200. So the equipment's all there. The payload, the test payload for the initial flights are there. I think we've got 99% of what we need for initial flight. We are a bit rusty as a group in terms of not really having done much for the last 6 months, and I think that needs to change. And hopefully, with the support of the team, we will change that in the next couple of months. At this point, I will hand over to Chris. Chris, do you want to walk them through the next couple of slides?
I've been involved with Trevor, helping him to share some of the burden, because poor Trevor shoulders a great deal of the responsibility for the group. So I've tried to take some of the workload from Trevor as much as I can. The main purpose of this talk with the EMRDC members is to try and see how it's possible for you to participate in launches and how your members can participate. So we want you to come. We really, really want you to come or be involved in some way. Obviously, with your skill set, we want you to track the balloon, and whether that's through your home base or join us in a chase car with your own tracking, that would be awesome. So what we've got is we've got some development to do on our launch platform, and we've got to integrate our payload for launch. What do we mean by payload integration? Well, I suppose it's in a foam box. All our electronic components are in the foam box, and they've got to be, the way that they're laid out, the way the camera is attached, where the aerial is for transmission to the ground, how the parachute is attached. All these things need to be sorted out, and they need to be practiced so that the team knows what they're doing, and each individual person knows what they're doing on launch day. We need to get together on a regular basis so that we can test the payload. We have done this already to a great extent, but as Trevor pointed out, we're a bit rusty recently. So we need to get together and retest the payload to make sure our electronics is working, and that telemetry is being received, and that it's taking pictures, basically that everything's working. We want people to come and support our launch activities on the launch day. And that means, if you're just coming along to observe, that's fine. If you want to get involved, even better. That's why we're inviting everybody to set up their own chase car if that's what they want, and come and help us try and retrieve the payload. Okay, so if we move on to the next slide, schedule of activities. What we're hoping to do is actually, over the next few months, is build up to our first launch. We've overcome 99% of the hurdles, as Trevor has outlined previously, but there still remains a few things. And one of those things is just getting the chase cars working, actually formally set a date for the launch. And as the launch date gets closer and closer, our AI modeling becomes more and more accurate. The further out you are, the less accurate, and as it approaches, it gets more and more accurate, so you have a better idea of where approximately it's going to land and if the launch is going to go ahead or it's going to be aborted because it's over water or in restricted airspace. We want to run some launch simulations and run through our launch checklists. The other thing that we've been doing is, contacting councils, making sure that they have approved the availability of the launch sites. We had 3 launch sites. We've sort of narrowed that down to 2 now. One of them was on private land where we had permission from the owner of the land, and another one is council-owned land where we need the council permission. The other thing that we need to do is obviously test the remote tracking and the chase car setup. So moving on from March to April, we want to have our first launch with a very, very simplistic payload, nothing too fancy, maybe just a camera taking a picture every minute, and two tracking systems, so we've got redundancy. And then if we have that particular launch is successful, then we want to duplicate or build on our success and launch with maybe a slightly larger payload. Maybe we want to add some sensors, maybe we want to increase the number of cameras that we have and the types of photographs that we're taking. And then finally, in October and next year, first of all, another maybe change in the payload complexity and the arrangement and the things that are inside that foam box. More sensors, more cameras, whatever we decide to go with to improve our systems based on, what's happened in previous launches. And then finally, next year, we've got at least one very dedicated member who is pushing for us to go with a custom built system. So we're talking about, custom built PCBs. You can go on to the next slide. So finally, there we go. I've on purpose haven't gone into huge detail about all the points that I've just made. However, here's your opportunity to ask questions.
Thank you for that, Chris. Mark, thanks for the presentation as well. John, Martin, thanks for giving us the opportunity to grow the club and also basically hopefully have some launches later this year. So Q&A, I know we've gone over an hour. It might be really long for you, but those of you who've got questions, we would, we are happy to take any questions, including Mark. If Mark's still around, any questions that you have for Mark, yeah, go for it, guys.
Trevor and Chris and Mark, thank you very much for coming this evening. I'll just take the opportunity to offer my appreciation on behalf of the club and members. Certainly the work you're doing is a very exciting opportunity, I think, for members to get involved and perhaps support, at least in part, your endeavours. So well done, gentlemen. To be congratulated.
Thanks very much for that. Much appreciated.